Ever wondered what's actually holding together the complex, interactive websites you use every single day? Well, today, we're pulling back the curtain on the invisible architecture of the modern web, front-end frameworks.
So here's our roadmap. We're going to trace the story of how web development went from total chaos to this super organized process, hitting new problems at every turn, all of which led to the incredible tools developers are using right now.
All right, first things first. To really get why these frameworks even exist, we've got to rewind the clock and look at the first huge problem that developers ran into.
You know, in the early days, websites were basically just simple documents. But as our ambitions got bigger, they turned into these massive, interactive applications. Think Weibo or Facebook. And all of a sudden, the code behind them just became this tangled, unmanageable mess. Developers were frankly pulling their hair out trying to find a better way to build. Here's a good way to think about it. Pretty much anyone can hammer together a simple shack, right? But you can't build a skyscraper that way. No way. You need blueprints, you need specialized teams, prefabricated parts. For the web, front-end frameworks became those essential blueprints.
So, the first real breakthrough in taming all this chaos was to create a structured blueprint for the code itself, a way to give every single part of the application its own distinct job.
This blueprint started by separating out the brains of the operation, what we call the model. The model is all about the data and the business rules. So if you're on a shopping site, the model is what handles the product prices, what's in stock, that kind of stuff. It has no idea what the Add to Cart button looks like. It just manages all the information behind the scenes. Next up, you've got the view. This is the face of the application. It's everything you actually see and click on. Its only job is to take the information the model gives it and make it look pretty for you, the user.
And finally, there's the controller. Think of the controller as the traffic cop standing between the brain and the face. When you click a button on the view, the controller grabs that request, tells the model, hey, update your data, add this item to the cart, and then it turns to the view and says, okay, show the user their cart has been updated. Now, this whole system, model, view, controller, or MVC, was a huge step forward. It meant different teams could work on the logic and the design at the same time, which really sped things up. But, you know, it wasn't perfect. For small projects, it felt like using a sledgehammer to crack a nut, and when something went wrong, trying to trace the problem through all those layers could be a real headache.
And this, of course, led to an evolution. Developers started cooking up new patterns like MVP and MVVM. The big idea here was to decouple the user interface from the data logic. Basically, they wanted to make it so the view didn't have to know anything at all about how the model was structured. This made the code way cleaner, much more flexible, and a whole lot easier to test.
But just as developers were finally getting their code organized, the world threw them a massive curveball. The web wasn't just for desktops anymore.
Suddenly, with the explosion of smartphones and tablets, that one website had to look absolutely perfect, not just on a big monitor, but on a tiny phone screen held sideways, on a tablet, you name it. The old one-size-fits-all approach was officially dead.
The answer was something called responsive design. Tools like Bootstrap gave developers a flexible grid system. It's almost like digital graph paper that could automatically refold itself to fit any screen. And at the same time, a new feature in CSS called media queries gave websites a kind of awareness. It allowed the site to literally ask, hey, am I on a phone right now? And if the answer was yes, it could completely change its own layout to be way more mobile-friendly.
Okay, so solving these two giant challenges, the internal complexity of the code and the external diversity of screens, required a whole new generation of even more powerful tools. And this brings us to the modern front-end frameworks.
This is when the major players we know today entered the scene. For instance, React started out as just an internal prototype at Facebook called Fax.js way back in 2011. It worked so well, they used it on Instagram the next year, and then in 2013, they released it to the entire world.
And that brings us to the big three you hear about all the time. Now, they all solve the same core problems, but they have really different philosophies. React from Facebook thinks about a user interface as a set of reusable Lego bricks called components. Vue is famous for being easy to get started with. You can just sprinkle it onto an existing page to add some cool interactivity, or you can use it to build a massive application from the ground up. And then there's Angular from Google, which is more like an all-in-one toolkit. It's pretty rigid. It gives you a strict structure to follow, which can be fantastic for huge corporate-level projects where consistency is everything.
But here's the thing. Building the application is only half the battle. Making it fast, efficient, and buttery smooth for the user? Well, that's the constant, ongoing quest.
And this is where optimization becomes absolutely critical. Every single bit of code matters for the user's experience. This means cleaning up the HTML so the browser doesn't have to work as hard, cutting out repetitive CSS so the site loads in the blink of an eye, and writing smarter JavaScript that runs super fast without bogging down your phone or computer.
And that's really the key takeaway here. Front-end frameworks aren't just some random collection of code. They are the direct result of decades of problem solving. They are the essential blueprints and the prefabricated parts that allow developers to build the complex, responsive, and lightning-fast applications we all rely on every single day.
So that leaves us with a final thought. We've seen frameworks evolve to solve these huge problems of complexity and all our different screen sizes. So as our devices get even smarter and our demands on the web just continue to grow, what new, maybe unforeseen challenges will the next generation of these frameworks have to overcome?